Good afternoon, everyone. This is Mike O'Malley here with a briefing on the minimal severe weather potential tomorrow across portions of eastern Oklahoma and northwestern Arkansas and extreme southern Missouri. The Storm Prediction Center has issued a marginal risk for severe weather for those areas, mainly for the threat of tornadoes. This is a 2% tornado risk, again, a very low end marginal risk, and we'll go over why that is here in just a moment, and a low wind risk across the area with a only a 5% low end marginal risk. So yeah, not really expecting tomorrow to be a big severe weather day, but there is some interesting parameters out there that we could see maybe one or two isolated supercell thunderstorms, or maybe even a Boeing segment or two move through those areas. So if we look down here at Corpus Christi, we'll actually jump here to the Norman sounding, 12Z Norman sounding earlier. This was the 7 a.m. Time. Again, we noticed that what was actually occurring at Norman was a surface temperature of 33 degrees with a surface dew point of 31. So relative humidity wise was pretty high, but definitely not anything of significant note here. Big capping inversion out here, big stout capping inversion, followed by a pretty weak to moderate lapse rate across that area. Again, you can see a lot of semblance of this dry air just above the surface. Again, only a 31 surface dew point, so the dew points really weren't that high. If we move further southward, if we kind of move further towards the south, we'll jump back down to Corpus Christi, Texas. So this is getting now towards the coast, and you can start to see that we transition from 30s dew points and very cold air to 54 over 53. So we've transitioned into a modest environment. Now, one of the things, again, very still a weak lapse rate that's noted out here in the mid levels. Again, you still have some of this mixing going on in the atmosphere between different kind of signals and whatnot. But generally, what we're kind of looking at is sort of like this environment where there's some marginal dew point temperatures. And as we get least cyclogenesis that occurs across the Colorado Rockies tomorrow, some of this is going to be advected northward and into parts of eastern Oklahoma and northwestern Arkansas. So, how does this look on the conceptual GFS forecast? We'll take a look here at a couple forecasts here real quickly. But this is the GFS forecast. This is the 12Z run, valid for 1 p.m. this afternoon. Again, you can see all is quiet across the area. Generally speaking, we have what's going to be taking place, least cyclogenesis across the Colorado Rockies, ejecting generally out towards the north and east over the next several days or so. And we can see what happens is that by tomorrow, this is by 9Z tomorrow, so just a little bit past, or just a little bit before sunrise, or 7 a.m. really, we start to really kind of pump out this least cyclogenesis that occurs. And again, this is generally moving towards the north and east. You can already see convection that's breaking out here across parts of Oklahoma and Texas. Now, again, looking at a direct sounding across parts of eastern Oklahoma at this moment, temperatures have advected. They've actually warmed into the 50s. So we've actually warmed our temperatures, and that again is a response because this least cycle. You can generally see southward moving air across here, all these kind of wind barbs here, or basically the isobars generally coming out of the south. So we're starting to affect some of that warmer moisture air up into parts of eastern Oklahoma. But you notice that there was a big capping inversion. Now, a lot of this right here is going to be elevated convection. A lot of this is going to be mainly elevated, and a lot of it is going to be forced ascent. So we're not going to be seeing any discrete supercells that are going to fire right along this axis. And again, behind it, you've got the cold air and the snow behind it, and in the warm sector, generally elevated convection at this moment. Now, if we jump out here, we'll look here. This is 12Z, so this is actually 7 a.m. on the east coast. This is still, right around the 12Z synoptic time. Again, you continue to see that low begin to deepen. The gradients are tightening, and in response, again, we get this forced descent that's out in front of this low in the approaching front, and this is going to be what we're going to be watching. This forced descent, moving these showers and thunderstorms away generally towards the north and east. And there's going to be something that's going to be happening in response to that. If we actually look here at the dew point temperature here, again, this is what today is. This is the 12Z synoptic time. Will go out to 18Z. And what you'll notice is that, again, these dew points are very bone dry at the moment. There's absolutely no dew points to be speaking of that would support any sort of convection at the moment. Now, if we move forward, we can start to see this is 0Z tonight, so this is right around roughly right around 8 p.m. Eastern time. We start to see that these dew points are beginning to creep northward. All these 40 dew points, and again, if you remember what we were looking at on the sounding, Corpus Christi with a 53 dew point, right now Fort Worth is at a 33 dew point. So by 7 p.m. or 8 p.m. Eastern time tonight, these dew points should be affecting northward into the 40s, and that's because we're beginning to get lee cyclogenesis, and that eventually all of that is going to transport this moisture into parts of eastern Oklahoma. Now, if we continue forward, this is 12Z tomorrow. Again, we've started to evict some of that moisture. Again, it's not a lot, and certainly not a lot that would conditionally support surface-based thunderstorms, surface-based convection at the moment. A lot of this is spelling of basically elevated convection at the moment. Not really something that would scream a surface-based event at the moment. But here we are by 18Z, and again, you can very clearly see where this front is. This area of low pressure is sitting right about here, and we have this trailing frontal boundary that's positioned back across here, and the warm front is moving somewhere up in like here. So we've got the warm front affecting northward, and again, right back, generally speaking, in this area is where we're going to be watching for that forced descent and a possible line of storms to develop. Now, again, we're not going to be seeing a lot of 60s and 70s dew points. Again, you can see barely only squeaking out 56 there across southern parts of eastern Texas, really, far south of the Red River. But we can continue to see that the moisture does hold along, and it would be marginally conducive for surface-based instability at that time. But if we look here at the 500 millibar flow aloft, and we actually just kind of look here at the 500 heights, again, what we have right now, generally a ridge across most of the area. This has been promoting that really cold air, and it's kind of been diving down. But you'll notice what starts to happen as we start to get lee cyclogenesis occurring. We get this trough that's ejecting outward and towards the north and east. And towards the east of that, you're going to have your zone for forced descent, just to the east of where this low develops. But again, you can see a problem with that is you're not getting a lot of southerly flow in the mid and upper levels. Again, at 500 millibars, this is roughly about 18,400 feet. You're not really getting a lot of that southerly ejection like we would like to see in those big severe weather days. So this really is going to be pulling in really a lot of dry air on the back side of this, because this is all southwesterly flow aloft, and because of that, you're sitting with a lot of dry air. If we actually look at a sounding back across West Texas, you can see that dew points are only marginally there, around 45, right around 45. So you're not really looking at a very strong synoptic system that would be pumping these dew points from the Gulf of Mexico with a long return flow. You're just not really getting that. And as such, we can also see that if we actually look at surface-based instability at this time, these surface-based CAPE values really struggle with the highest CAPE values, probably only getting to right around 300 CAPE or whatever, and barely just some semblance, maybe 100 to 200 CAPE surface-based across this area. And if we take a representative sounding, let's just say this is 21Z tomorrow, so most of this would be already gone, but you can see even the photographs are not especially curved. I mean, you have somewhat of a symbol of curved photograph in the first 0 to 1 kilometer. So if you just kind of sketch all that out here, that would be basically your storm relative helicity. But those storm relative helicity numbers wouldn't be especially large. And that's certainly one thing. The instability is lacking, and there's definitely some convective inhibition across the area to really lack any significant thing there. Looking at the 18Z rapid refresh or the HER model, again, just real briefly, again, you notice that convection begins. You can see that forced descent really occurring with elevated convection developing across parts of the Texas Panhandle and across West Texas by about 8Z. And by the time we get to about 12Z tomorrow, you can see some of that forced convection. A lot of this is going to be elevated. And as it moves into parts of Oklahoma, really, and Arkansas, you can see just maybe some semblance of some broken bands in through here. Again, a sounding at this time, if we just kind of move backwards, a sounding across parts of northwestern Arkansas really represents that the environment is not really favorable there. But this hodograph is exceptionally large. It's an elongated curved hodograph. That would definitely support and squeak out thunderstorms in that environment or rotating updrafts. However, we need convection at that time. We need surface based convection. The fact that our temperatures are going to be barely squeaking out of the 40s at this time is really going to make it hard for any surface based instability. And if we look here, maybe by about 18Z, this is right around 2 p.m. Eastern time, our temperatures maybe get up there. Definitely have a very strong hodograph. I think this is maybe a little bit convectively contaminated. So we'll jump down here to kind of far western Arkansas there, but these hodographs are exceptionally enlarged and they would definitely support supercells in that environment. However, again, you're likely not going to see a very significant response in the low levels. And if we actually look here at the dew point temperature, our dew points again tomorrow are going to be generally squeaking right around 40. You can see those some of the 60 dew points there across parts of far southern Texas at the moment, but those fail to get much northward, and you barely get dew points that are in the low 50s across parts of this area in the marginal risk. So, conditionally, the environment is supportive for rotating updrafts and supercells if we can get surface based instability. That's why there's a marginal risk there, because any surface based thunderstorms that do manage to develop under some of that marginally conductive surface-based cape may have a chance to promote some surface-based thunderstorms, which may try to develop into discrete supercells. But again, with this forced descent that we're going to be seeing, again, because the way the boundary orientation is, this will likely suggest that we're going to be seeing somewhat of a broken line. So we're probably not going to see individually discrete supercells in this environment. Certainly is not a classical supercell setup, but we could see maybe a cold core tornado setup happen tomorrow. Maybe some marginally conducive conditions for some of those surface-based thunderstorms to develop. If they do, there is a chance for severe storms, including the threat for isolated tornadoes. That's why the risk is present. Other than that, not a very huge risk outside of that. Hope you all have a great rest of your afternoon and evening. The off-season hurricane outlook and discussion will be produced, and it will be out likely by Saturday or Sunday, just for your reference. Have a great rest of your afternoon and evening. Of course, this is Michael O'Malley. I'll talk to you guys again some more later.